So, let's have a look at this question. Sally is trying to row directly across the river, but the river is flowing with a velocity of 4 meters per second parallel to the banks, which means that Sally won't go straight across the river. She's going to go at an angle. She can row at 3 meters per second, so we need to work out the resultant velocity of the boat and also what direction is she going to go in. Let's have a look at that, remembering that we can use Pythagoras' theorem. So here we have the two velocities that we need to consider in this case. The velocity of the river flowing along and the velocity of Sally as she's rowing across the river. Now we've got two vectors that are at right angles, and if I just draw in the rectangle there, you can see that we've got a right angle triangle, so we can use Pythagoras' theorem. And if we do that, we can work out that the velocity at which Sally is actually going to be rowing is 5 meters per second at an angle to the bank. And again, we can work out the angle that she's rowing at, which turns out to be 37 degrees. So the resultant velocity, the velocity that Sally's actually moving at, is 5 meters per second at an angle of 37 degrees to the bank of the river. Now, in general, A-level questions will only ask you questions with velocity to work out when you've got vectors that are at right angles to each other. If you're expected to work out vectors that aren't at right angles, you'll usually do it by scale drawing, as we did earlier. Now, have a look at this question. We have a ball that's bouncing, and what's its change in velocity? It starts off going downwards at 8 meters per second, and then it bounces back up at 5 meters per second. So notice that the speed has changed and the velocity has changed. So the change in velocity is the final velocity. Take away the initial velocity. We put our numbers in. Now notice here we've taken that down is negative. So anything bouncing upwards is positive, anything bouncing downwards is negative, which gives us a change in velocity of 13 meters per second. Notice that the change in speed would have been 3 meters per second, because when we're looking at speed, which is a scalar quantity, it doesn't matter about direction. But for velocity, which is a vector quantity, the direction is important. So in this case, the velocity, change in velocity is 13 meters per second in an upwards direction. If we want to subtract a vector, then it's the same as adding a vector, but of the same magnitude in the opposite direction. So let's have a look at that. If we want to subtract these two vectors, well, the first thing we need to do is make a new vector of the opposite magnitude, but the same direction. So we put our new vector in there, and then we draw the resultant. Move the vectors tip to tail, and draw the resultant, and we can complete the triangle to find the resultant. So, have a go at these two questions.